So this video is to show you how to do the calculations to figure out what quantities you need to add to your functions in order to set up your pulse width modulation module on your microchip. In other words, there's several functions that you're going to call to get your PWM module working, but two of them have a number that you need to calculate first. So I'm going to show you how you calculate those numbers that you need. So these two equations show you how to calculate what you need. And I'll give you a heads up. You're going to need this number for one of your functions and this number for the other one. So first, let me explain what some of these symbols mean. PWM is the period of the signal that you're trying to get. So for example, if you want a wave that's 520 hertz, then the period would be 1 over 520 here. TCY is just your instruction cycle. So that's set by the computer chip. And I'll just turn on some values here. So in our case, if you're running the chip at 48 megahertz, then TCY is going to be 4 over 48 megahertz. So this is a set value. This is something we are aiming for. We know what we want here. So we have two unknowns. We've got this T2PR and this TMR2 prescale value, which we get to choose. Down here below, we've got the pulse width. So what's that? Well, that's going to be the on cycle. In other words, you're trying to set the duty cycle with this equation here. So if you want a duty cycle of 65%, this pulse width would be 65% of your period up here. TOSC is the period that comes from the oscillator frequency on the microchip. So again, in the case of a chip that's running at 48 megahertz, TOSC would just be 1 over 48 megahertz. In the two equations, the prescale has to be the same. Now, as I've also pointed out, this number here, which is going to be the value that we plug into our function later, can only go up to 255. Likewise, duty cycle, which is also a quantity that we need to plug into a function later, can only take a maximum value of 1023. So now let me explain how you use this first function to figure out what value you need here in order to get the period that you're aiming for. Now I'm going to do my calculation down here at the bottom, and I'm going to start by doing the calculation on this first equation up here for the period. Now in this first equation, we do have a bit of an issue in that we do want this T2PR quantity, but we also have another unknown, which is the prescale value. So the prescale value is something we get to choose, but it does mean we have these two unknowns. And it is this value that we want to get, but we need to choose the prescale first. So how do we do that? Well, what I recommend you do is that we're going to put in the maximum value here and then calculate an approximate prescale value. So that's what I'll do first. So to begin with, we have to choose what we want the period to be. So as an example, I said, let's say that we want a period such that the frequency of this is going to be 520 hertz. So T/PWM is just going to be equal to 1 over 520 seconds. And as I said, we're going to swap in the maximum value for this T2PR. And then we'll have the prescaler, which we're trying to find, and then TCY, which is set by our microchip. So now we've got these values, and we can just plug this into our calculator and solve for the prescaler, which in this case turns out to be 90. Now the thing is, there's only certain values for the prescaler that we can use, so we're going to take this value and round it up to the nearest prescaler value that we're allowed to have, which is 128 in this case. So if we had found that our approximate prescaler was 27, we'd round up to 32. If it was 54, we'd round up to 64. So we've done one half of this now. We've found what our prescaler is going to be. We're going to use 128 for both of these equations. So the next step is then to go through this top equation again, except this time we're going to use the prescaler we just came up with, and we're going to calculate what this T2PR is actually supposed to be. So now we're calculating the value that we wanted all along. So let's do that now. Our period is still 1 over 520 hertz. We're now looking for T2PR, and we know our prescaler is going to be 128, and the TCY is still the same. And so now we can solve for T2PR. And if you plug that into your calculator, you find that it's 179. So this here is the quantity that we're going to want to plug into the function that sets TPWM to the correct value for us. And by the way, this quantity is also called period val in your lab manual. So next, we want to set the pulse width. So let's do that now. So the pulse width is how long the square wave is going to be high for. So let's say that I want my duty cycle to be 65%. So that means the pulse width is going to be 65% of my period, which was 520 hertz, and that'll be equal to duty cycle, which is what we're trying to find right now, times the prescaler, which has to be the same value that we used previously, and then times the period of the microchip, which in our case would just be 1/48 megahertz. So again, you plug this into your calculator and you solve for the duty cycle, which is about 469. So this is the quantity that we're going to need to put into our second function in order to set the pulse width to 65% of the period. So again, just to quickly recap, you first plug in the maximum value that you can here as a temporary value for this T2PR, and then you use that to get an approximate value for your prescaler, and then whatever value you get, you round it up to an actual prescaler value, since there's a limited number of them. Once you've got your prescaler, then you plug it in for real, the actual value that you're using, and you solve for your T2PR value, which is what you want. And finally, after you've gotten that, you also want to get your pulse width, which should be simple to get because at that point you already know what your prescale value should be, and you just solve for the duty cycle. And that gives you the two quantities, duty cycle and period val, which will allow you to use the PWM module to put out a square wave that has the period and the duty cycle that you specified.